In this lecture, we will continue chapter 2 from the book. This is pharmacoepidemiology. In chapter 2, the author introduces tools for epidemiology, and we went over the lecture regarding the incidence, prevalence, regarding the different type of incidences and different type of prevalences. Also, we discussed the rate, ratio, etc. However, when the book starts talking about measures of association, I prefer to do this using my own lecture because I want to delve into it in much more details. So this lecture is probably going to be long, and there will be a lot of calculations, a lot of explanations, a lot of differences, and I'm gonna cover all of this in as much details as I can, and trying to make sense of all of this. Um, what I would like also to note that I will talk about the measures associations with regard to the design of the study. At this stage, we may have or may not have discussed the major types of research design. So, in few words, let me just remind you, though we will have specific lectures talking about cohort, RCT, case control, and other designs, but you have seen this in PHA 421. We covered these in a very briefly in PHA 41. So let me just remind you of the major thing about the different designs. Um, Specifically, we talked about the fact that we have experimental design, and then on the other hand, we have non-experimental design. Okay. And in experimental design, the design or what matters for that for us is that you get a group, you get a sample, and then you put your sample randomly or non-randomly, and you either randomize or do not randomize them into either receiving the treatment or receiving the placebo. And then there is a follow-up that will happen, and through this follow-up, you're going to start noticing um, cases or incidences. So new outcomes are going to emerge. So these are outcomes here and in the other arm. And these are new outcomes, and therefore we refer to them as incidences. In the non-experimental design, في عنا two major arms of non-experimental design. في عنا the first arm that looks like experimental design, which is called the cohort, and basically it's the same concept. What is happening is that people themselves are either exposing themselves or not exposing themselves. So they're either taking the drug or not taking the drug, which is exactly like what is happening here, except that that this is people decision right here. This is people decision. This is study decision. And again, there will be a follow up, and so both of these designs that I discussed are called prospective designs because you're starting up with the exposure and you're following up till the occurrence of the outcome. And all the outcomes in both designs are new outcomes, and hence we talk about incidence. The last, يعني, let me say, maybe it's not the word last, but anyway, so the other design under non-experimental is actually case control, and case control is considered to be a retrospective design because you're not starting with the exposure, rather, you're starting with those that have the outcome. So either the outcome is present or the outcome is absent. So that's your start. So these are called cases and these are called controls. That's your starting point. And then you assess the exposure back, and therefore it's considered retrospective design. At any rate, these are not new cases. These are prevalent, I mean, the ones that are. So you start with prevalence and then you go back, assess the exposure. And therefore, you cannot talk about incidence, you talk about prevalence, prevalent cases. And the last design that falls under non-experimental is also non-experimental. It's called the cross-sectional. And basically, the cross-sectional, what happens is that you're going to come and at one point in time take a group of people, and after you take them, then you will look if they are exposed and if they have the outcome. Okay? And in a nutshell, both the experimental design and the cohort is a design that starts with the exposure or not exposure. So your sampling or your starting point is exposed, not exposed. Then you do a follow up in real time or in, well, follow up. Let's say خلاص, a follow up. So it's a prospective till the occurrence of the outcome, and the outcomes are new cases. They're called incident cases, and therefore they're new. Whereas in the case control, you start up by the end, yani start up by the outcome, and then retrospectively you're going to assess the exposure, and therefore case control is called retrospective. The last design is cross-sectional, where the selection is independent of exposure or outcome. You just take a sample, and after the sample is obtained, you look at whether they are exposed or not. The first two allow the calculation of incidence. The last one allow the calculation of prevalence. Okay, and case control is a different story, which we will talk about later on in the lecture. So going back to the lecture, I'm starting with how to calculate measures of association in the cohort and the RCT. So I'm putting together cohort and RCT because the rationale, the way it is set up is exactly the same, except that one is experimental, the other is not experimental. All right. And when we talk about measures of association, that is association between what? Between the independent variable and the dependent variable, yani between the exposure and the outcome. And therefore, we're going to talk about relative risk. We're going to talk about odds ratio, attributable risk, and number needed to treat. All these four things can be calculated in the following, in the designs we just mentioned, اللي هن, RCT and cohort. Maybe number needed to treat is just for RCT. All right, so basically this is the main setup of an RCT or a cohort. You start off with the exposed and the not exposed. At the beginning, none of them has the outcome. So whole exposed, you follow them in time, and some of them are going to develop the outcome, the disease, the incidence, whatever it is, and they are represented by letter A. Those that are exposed but do not develop it are represented by letter B, and the total is A plus B. Same rationale. Those that are not exposed, you follow them in time, and then the present is represented by letter C and letter D for the absent of the outcome, and the total is C plus D. What I want out of this table is that this setup of this table where you have the exposed, not exposed here, and the disease is present and absent here. So formulating this 2 by 2 table, you're only allowed to calculate values within the exposed and within the not exposed. Okay, and the reason behind that is that this number of total exposed and the total number of not exposed is your starting point. This number is not representative of what is happening in the population. This number, you as a researcher decided that you might want to take 500 exposed and give them the drug, and maybe 500 not give them the drug, or whatever the number is. So you have decided what is your total A plus B and what is your total C plus D, and therefore, or any kind of calculation, you're only allowed to do it within the exposed alone and within the not exposed alone. You're not allowed to calculate across. You're not allowed to come and say, what is the total incidence rate. That is not allowed. Okay, so let's continue and look at what I mean by that. Okay, so if I'm looking at the incident of the exposed group, if I take those that have developed the outcome and I divide by the total exposed, so A على A plus B, this is your incidence in the exposed group. This is your incidence rate in the exposed group. Also, remember, ممنوع حدا at the beginning يكون عنده outcome in a cohort or in a RCT. So everybody is free at the beginning, and all the A's are actually new cases, incident cases, and therefore A على A plus B is considered an incident rate in the exposed. And also, we may refer to it as risk of the outcome in the exposed group. Okay? In the exposed group, because I'm only calculating within the exposed group. Similarly, you can do the same thing in the not exposed group. You take those that got the outcome, you divide by the total for only not exposed, and that would be your incidence of the outcome, the incidence of whatever it's the disease or the adverse drug reaction, or maybe the need for uh, follow-up treatment or whatever it is your outcome, then C على C plus D is your incidence in the non-exposed group. Also, we can refer to that as the risk of the outcome in the non-exposed group. I'm being specific, the risk in the non-exposed group. A minute ago, I was saying the risk in the exposed group. I'm not saying the risk in general. That would require different study design. So after we've calculated the risk in the exposed and the risk in the not exposed, then it comes rationally that you would like to compare these two risks. You would like to evaluate these. How do these two risks compare to one another? One thing you can do is you can calculate a difference between the risks. So that would be called the absolute risk difference. Yani risk group 1 minus risk group 2. However, another thing that is commonly used and very popular is actually calculating what is called a relative risk. A relative risk is a risk ratio. Now, you remember what a ratio, right? A ratio, the numerator and the denominator are two different values. So if you take the risk in the exposed and you put it on the risk in the not exposed, well, this is a ratio. Okay, and here you've calculated a risk ratio. So risk in the exposed divided by the risk in the not exposed, that will give you a risk ratio. And obviously, if, for example, the risk in the exposed is 6% and the not exposed is 3%, the ratio will come out to be equal to 2. And therefore, if your relative risk or risk ratio is equal to 2, it means the risk in the exposed group is twice as much as that of the not exposed group. Okay, so relatively speaking, if you were exposed, your risk is twice as much, twice as bigger than if you're not exposed. That's the concept of relative risk, and it can only be calculated if you have new cases so that you can calculate risk. And the only two designs that allow you to calculate new cases are cohort design and RCT. So what does it mean? Relative risk is a measure of the magnitude of the association between the exposure and the disease. The bigger the relative risk, the stronger the association. And that should take you back to the Bradfield Hill criteria for causality. Number one, again, the strength of the association. So you can look at your relative risk and see how big it is. Now, how do you evaluate a relative risk? Well, a relative risk is a value that goes between 0 all the way to, theoretically speaking, infinity. Or maybe I should say finity. Um, um, and a relative risk, بما أنه it's a ratio, when both risks are the same, so right here you have, so it starts at 0, a relative risk cannot be negative. 1, this is where both risks are equal to one another, so risk in the exposed equal risk in the not exposed. When both risks are equal to one another, the relative risk will be equal to 1. When the risk in the exposed is greater than the risk in the not exposed, معناتها the exposure is increasing the risk, you will be in this area here, okay, where the relative risk is greater than 1. However, if the risk in the exposed group is smaller than the risk in the not exposed, maybe here your drug is protecting against a certain outcome, then you will be in the blue area and the relative risk is less than 1. A strong relative risk is a relative risk that is going away from 1, either on this side or on that side. Okay, the further away you are from 1, the stronger the relative risk. On this side, we talk about a positive association between the exposure and the outcome. On this side, we talk about a negative association between the exposure and the outcome. Okay? So, one last thing I should mention here, and I'll probably mention it later on, is that another thing about relative risk is that you need to assess it for statistical significance. Like anything we do, you need to check statistical significance. And for those of you that would like to review the um, the review lecture on testing hypothesis, that might be a good time. Basically, before you can start evaluating your relative risk, so if you got a relative risk equals to 2, okay, before you do any kind of evaluation, you want to check if this is statistically significant. And once you check that it's statistically significant, you can come and you can evaluate it and talk about what does it mean a relative risk of 2. Same thing if your relative risk was 0.75. Okay. Of note, the null hypothesis for a relative risk, you can say there's no difference in the risk between the exposed and not exposed. Or, as we've mentioned, when there is no difference, the relative risk is 1. So your null hypothesis could be that the relative risk in the population, okay, is equal to 1. This is your null hypothesis, okay? And when your p-value is less than alpha, you reject this null hypothesis, and therefore you declare that there is an association between the exposure and the outcome. So let's go back to the lecture. So مثل ما كنا عم نقول relative risk is a measure of the magnitude of the association between the exposure and the disease. The further away it's stronger, and it tells you if it's a positive or negative, yani whether it's on greater than 1 or less than 1. It can be calculated if incident cases are available, يعني RCT or cohort. It can assume values from 0 to infinity, or let's say very large values. Though in practice you won't probably see any relative risk beyond 5, 6. Most relative risk are within like from 1 to 3, 4. That's the one I've seen. On the positive side, obviously. Value 1 of relative risk is indicative of no association between the exposure and the disease, right? We said this is when the risk in the exposed equal the risk of the not exposed. The relative risk would be equal to 1. The risk difference will be equal to 0. Yeah, but we're not doing risk difference. We're doing relative risk. So when it's equal to 1, it means that there's no association, no difference. Values less than 1 are indicative of a protective effect of the exposure. Yani the association is negative. When you're exposed, you have less of a risk to develop the outcome. Maybe maybe this is a drug that is supposed to reduce the risk of myocardial infarction. Values greater than 1 are indicative of an increased risk of the disease or the outcome, whatever that outcome is. So maybe like taking the drug increases the risk of fainting. And to know if it's statistically significant or not, you have to look at the p-value, as I mentioned, or at the confidence interval. So let's go back and one more word about confidence interval and p-value. Okay, so I told you that the null hypothesis indicate, so according to the null hypothesis says that the relative risk, so relative risk in the population, the real one, is equal to 1. Some books, they write it as something like this. This is equal to 1. This is in the population. The relative risk we calculate is from our sample, and it is an estimate. So if you get a relative risk of 2, to know if this is statistically significant or not, you have 2 routes. Route number 1 is to get a p-value. And the p-value, you're going to get it from a statistical test. It's the chi-square. Or you can calculate a confidence interval. And if you remember, a confidence interval is basically you take your estimate. So maybe the relative risk here, you take it. And so this is the estimate. And you build around it a fence, an interval. Okay? And any value inside the interval are possible values for the real population value. Okay? So if you build around the confidence interval around 2, and it comes out to be 0.9 as a lower limit all the way to 3.1 as an upper limit. Okay? All values inside are potential values of the real population. And since 1 is part of this interval, right? If you go from 0.9 to reach 3.1, you have to go through 1. So value 1 is a value that is inside the interval. Okay, so the real population relative risk could be equal to 1 according to what I just did. And therefore, this confidence interval indicates that we cannot reject the null hypothesis, and therefore, there's no statistical significance. Scenario number 2, you actually calculated a relative risk of 2, and the confidence interval came out to be 1.4 all the way to مثلا 2.2. Okay, in this scenario, value 1, which is the population relative risk when there is no association, is not included. Okay, think about it. This is 1 is right here. Your interval 1.4 starts here and it ends at 2.2 here. So you can see that 1 is not part of this interval. And therefore value 1 is rejected, and therefore we're rejecting the null hypothesis, and therefore we're concluding that there is statistically significant association. Okay, so real quick again, to know if your relative risk is statistically significant, you check your p-value. P-value has to be less than alpha, if you remember. Alpha is typically 0.05. If that is the case, then it is statistically significant and the association exists. That's one way to do it. The other way to do it is to do a confidence interval, and a confidence interval includes value 1. Yani going from a value less than 1 to a value greater than 1. That means the null hypothesis cannot be rejected, and therefore you fail to reject the null hypothesis and you declare that there is no association. Or your confidence interval does not include value 1. You're not passing through 1, okay? And therefore you declare that value 1 is not acceptable. You're going to reject it. You're going to reject the null hypothesis, and you're going to declare that there is statistical significance. All right, let's continue with the lecture. So we check the p-value or the confidence interval to know if the relative risk is statistically significant. So that concludes how to calculate a relative risk in a cohort or in RCT. بعدنا مكملين cohort RCT, so we're still within the setup where you only look at the exposed and the not exposed. Another thing you can do is you can calculate بدل the incidence rate, you can calculate the odds of the disease in the exposed group. Okay, notice I'm all in the exposed group because we're only allowed to look inside the exposed group. And therefore, if you take A and you divide it by B, مش by A plus B هالمرة, so it's no longer a proportion or incidence مثل ما عملنا من قبل. Now it's going to be the odds. The odds of what? Of the disease, because I'm taking A and I'm dividing it by B. So I'm taking the present and I'm dividing it by absent. So it's the odds of the disease or the odds of the outcome, whatever that outcome. However, specifically in the exposed group, that's A over B. So that's the first odds. The second odd I can calculate is كمان الodd of the disease, but this time in the not exposed group. So again, I go back to the not exposed group. I focus only on them, and I take the disease present divided by disease absent. This is an odd, right? We learned that when you take a value and divide it by another value that is not included, it's an odd. Somebody may say, well, this is a ratio. Come in, it's true. So this is the odd of the disease divided in the not exposed, and that هيك بصير عندنا two types of odd. Maybe I need to just remind you the odds. What is the odds? Now it came to my mind. You may remember back in the days when we were talking about probability, we said the probability of an event is the number of success, like all the way types, different ways success can occur, divided by all possibilities. All possibilities, okay? Now this is called a probability, a proportion as well, a percentage, okay? So like if you have a class where in a class of 30 لنقول 10 are male and 20 are female, then the probability or the proportion of male, so proportion of خلينا نقول female, proportion of female would be the success, which I defined it to be female, so I have 20 female, and it's divided by everybody, so it's divided by 30. So this is 20 over 32 over 3, okay? This is probability, proportion, or percentage. However, there is another thing that is called the odds of an event, where you're going to take the success exactly like what we did over here, but you do not divide by all possibilities, you divide by failure. Okay? All right. So, again, if I want to know the odds of female, I would have to take the females, اللي هن 20, but I do not divide by everybody, I divide only by male. So only I divide by 10, and that gets me 2. Okay? So the odds of female to male is 2 to 1. All right? So that's what the odds is. To link it to things we've said before, probability is also a proportion, okay, and a proportion لأنه what's in denominator is also included in the denominator, whereas in odds it is a ratio because what is in the numerator is not part of the denominator. Okay, so this is called probability and this is called odds. And I have started talking about how to calculate the odds of the disease in the exposed group and the odds of the disease in the not exposed group. And similarly, for what we did a minute ago, where we started looking at two odds and we want to compare these two odds. While مثل ما عملنا relative risk or سميناها risk ratio, we can do also an odds ratio where you're going to get the odds of the disease in the exposed group divided by the odds of the disease in the not exposed group. And if you apply the formula A على B divided by C over D, by rearranging things, you will quickly discover that it's AD divided by CB. Okay, AD divided by BC. And the formula is quite simple because it's kind of like a cross product. Um, it's the yes cell multiplied by the no cell divided by the other two. You multiply the other two. Okay, so AD على BC is your odds ratio. And an odds ratio is very similar to a relative risk, meaning that كمان the universe or the space for an odds ratio starts at 0 and it spans to infinity, going through 1. And بما أنه it's a ratio, again, a value of 1 is indicative of the odds in the exposed. So odds in the exposed equal the odds in the not exposed, meaning there is no difference in the odds, meaning there is no association between the exposure and the outcome. Okay, so that's the odds ratio equal to 1, indicative of no association. And like we said for the relative risk, values that are spanning beyond 1, greater than 1, this is where the odds ratio is greater than 1, and that means that there is a positive association, yani the disease is more likely to be present as the exposure is present, whereas values below 1, this is a negative association, and hence the outcome is less likely to be present if the exposure is present. مثل ما قلنا very similar to relative risk, but the interpretation is different. So relative risk بنحكي على the risk is doubled, بنقول the risk of the outcome is double in the exposed versus the not exposed. Here we do not say the risk, we talk about the odds. The odds of the outcome is twice as much. And this difference, very people pay attention to it, but it has a lot of meaning because you're not calculating the same thing. You're not calculating risk. You will see that a lot of literature, they calculate odds ratio and they use it or they interpret it as if it's a relative risk. This is incorrect. Okay, so they calculate like an odds ratio of 3, بيقولوا the risk is 3 times bigger. That is wrong. We should not say the risk is 3 times bigger. We should say the odds of the outcome is 3 times bigger. or 3 times more likely. Yani you can use some format of words, but you should not talk about risk. Um, هلا in a cohort or in RCT, you can calculate both odds ratios and relative risk. You can calculate both of them. What I wanted to tell you is that the odds ratio compared to the relative risk actually it's more it's easier to interpret. So there's a much more people would like much better to look at the relative risk than to look at odds ratio. However, a lot of time we end up calculating odds ratio because of softwares are developed to calculate odds ratios. Another thing you need to know about the odds ratio, when both odds ratio and relative risk can be calculated, the odds ratio tends to be more inflated than the relative risk. And as your relative risk is 2, your odds ratio might be equal to 3.1. Okay, بيكون دايما inflated يعني away from 1. If your relative risk is for example 0.8, your odds ratio could be 0.7. Okay, كمان عم inflated لأنه this time you're going away from 1 on the lower end, on the left hand of the 1. Okay, so, and that's another reason why we should not interpret odds ratio as a relative risk, because when the risk usually in the reality is 2 times bigger, the odds ratio is appearing 3 times bigger. And if you come and you say the risk is 3 times, then that would be wrong. The risk would be much less than that bigger. Okay. So this is, as I said, the formula for the odds ratio. And بعدنا بالcohort أو RCT يعني you're calculating an odds of the outcome in the exposed على odds of the outcome in the not exposed. The reason I keep saying that is because in the case control we were going to calculate كمان an odds ratio, but the interpretation is going to be different. Okay. هون عم نطلع within exposed, within not exposed, we're calculating odds of the outcome in the exposed على odds of the outcome in the not exposed. All right, so let's do some calculation. Here's an example of a cohort of 3,000 people in total. The total number of exposed is 1,200. The not exposed is 1,800. Out of the 1,200, as they were followed up, 200 developed the disease or whatever the outcome is. حاطط هون incidence حتى to point out that these are new cases. And the not exposed 220. And therefore we're asked to calculate the incidence in the exposed, the incidence in the not exposed, or I can call it the risk in the exposed, the risk in the not exposed, to calculate the relative risk, our risk ratio, exactly the same thing, to calculate the odds, and to calculate the odds ratio. So to calculate the incidence in the exposed, so I for incidence and E for exposed, أو RE يعني risk in the exposed, risk of the outcome in the exposed, you're going to take the 200 and you're going to divide it by the 1,200. Okay, so 200 divided by 1,200, hopefully that will give you 0.1667. If you want, pause the video, do your calculation, and come back and make sure that I'm doing it correctly. Then we're going to calculate the risk in the not exposed. أو actually, let me write this هيك حتى you feel comfortable that this is exactly the same thing. The risk in the not exposed, or the incidence in the not exposed. And you're going to look at the not exposed group, and you're going to pick those that develop the outcome, the 220, and you're going to divide them by the 1,800, and you get 0.1222. Yani if you're exposed, you have 16.7% risk of getting the outcome. If you're not exposed, you have 12.22 risk of getting the outcome. Obviously, the risk in the exposed is bigger than the not exposed. How much bigger? That's where you're going to do the relative risk. You take the risk in the exposed, the 0.1667, you divide it by the risk in the not exposed, 0.1222, and that should give you a relative risk of 1.36. هلا, before we do anything else, we're supposed to get a p-value or confidence interval to tell us if it's statistically significant or not. But hypothetically speaking, if it is, the way we're going to interpret this relative risk, okay, we're going to say that the risk in the exposed is 1.36 times the risk in the not exposed. Okay, So 1.36 times in the not exposed. That's one way to do it. Another way to do it is to say that the risk in the exposed is 36% times greater than the not exposed. من وين جبت أنا 36%؟ So come in. So every time you calculate an odds ratio or a relative risk, if you get something like this, okay. So for the interpretation, you can either say it's the risk in the exposed is 1.36 times that of the not exposed, which is correct, or you can say 36% higher. لأنه the reference is 1 and you are at 1.36, so 1 minus 1.36 gets 0.36, and that's your 36%, which is also true if your relative risk happened to be less than 1. So if your relative risk is 0.8, you can say that the risk in the exposed is 0.8 times, yani less, or you can do the 1 minus, and that gets you 0.2, and this is 20%, and you can say that the risk in the exposed is 20% less than the risk in the not exposed. Okay, so in our case, the relative risk came out to be 1.36. We interpreted that. Let's calculate now the odds of the outcome in the exposed. So D, let's to say disease in the exposed. Okay, so you only look at the exposed and you're going to take the 200 and now you're going to divide by 1000. So that gives you 0.2. Also, you were going to do it in the not exposed, so the odds of the disease, so D for disease and NE and in the not exposed. So it's 220 divided by 1580, that's 0.139. Now we're going to do an odds ratio. You take this odds and you divide it by this odds, and you get an odds ratio of 1.44. Again, you're supposed to do a p-value or confidence interval. By the way, the confidence interval for odds ratio نفس الفكرة for relative risk. If it crosses 1, not statistically significant. If it does not cross 1, statistically significant. But for now, if I ask you to interpret this odds ratio of 1.44, you would say the odds of the disease in the exposed group is 1.44 that of the not exposed group. Or you can say the odds of the disease in the exposed group is 44% greater than in the not exposed group. And notice I'm saying odds, I'm not saying risk. لأنه for the same data, if you calculate the relative risk and the odds ratio, you will find out that the odds ratio is more inflated than the relative risk. As we mentioned previously, it is greater than the relative risk. Okay, so that takes us to the confidence interval. Confidence intervals are used as measures of statistical significance for relative risk or odds ratio, both. As I mentioned, a confidence interval, so CI stands for confidence interval, containing value 1 is indicative of no statistical significance. If it's not, is a confidence interval does not contain 1, then it's statistically significant. Also, another thing that I did not mention, but I will mention it هلا بعد شوي, that there is a direct relation between the percentage of your confidence interval and the alpha of the testing hypothesis. So confidence interval does not come هيك لحاله, this attached. Confidence interval comes with a percentage. So you're either 95% confident, or you're 99% confident, or you're 90% confident. And then depending upon the percentage you choose, there is a one-to-one relationship to the alpha. Okay, نحن قلنا most of the time alpha is 5%, so that relates to the 95% confidence interval. Complement لبعضهم. If your alpha was 1%, that relates to a 99% confidence interval. Okay, كمان complement لبعضهم. Mind you that if you choose to do the p-value, or if you choose to do the confidence interval, you will reach the same conclusion either way. Okay, they do not contradict one another, they will give you the same conclusion. All right, so come in one more review of confidence interval and the thing about one. So مثل ما قلنا, a relative risk or an odds ratio span from 0 passing through 1, and it's up, it's open on this side. So a confidence interval that starts here and ends here, this confidence interval is statistically significant. It did not cross 1. A confidence interval that started here and ended here, that's also statistically significant because it did not cross 1. Only when you start below 1 and you finish after 1, then it's a non-statistical significance. You're going to fail to reject because this value 1 here is inside the interval, and therefore it's an acceptable value, and therefore you cannot reject it, and thus you fail to reject your null hypothesis. That's on one hand. On the other hand, كلمة confidence interval كان wide، كلمة it's less precise، كلمة it's narrower، كلمة it's more precise. Okay, so the precision of the confidence interval is indirectly linked to its width. The narrower confidence interval, it's more precise. The wider it is, it's less precise. And in fact, there are two things that impact how much narrow or not narrow a confidence interval is. And these two things are the sample size and the percentage of how confident you want to be. Okay? كلمة sample size increases, the width of the interval gets smaller. The width gets smaller, and therefore the precision is higher. That's something that you're interested in getting. On the other hand, كلمة percent confidence is bigger. You're more and more confident. What happens is that the width gets bigger as well, and the precision gets smaller. Okay? We're going to do this in few slides, but maybe that's a good time for me to introduce that concept anyway. So generally speaking, a confidence interval is built using this formula. It is an estimate of the population value. Okay, and you're going to build around that estimate the interval. Okay, هيدي building around معناتها one time you're adding and one time you're subtracting from the estimate. So that's why sometimes you see me writing هيك estimate plus or minus the width. Okay, أو a distance. Okay, this distance, it's made of two parts. One part is a statistical test. So test times something called standard error. Okay, so that test is what relates to how confident you want to be. Okay, كلمة you want to be more confident, like 90% confident, 95% confident, 99% confident. Okay, the more confident you want to be, what is going to happen to this test that is part of the formula is that that test is going to get bigger and bigger. Test مثل الZ test, مثل الT test, مثل الchi-square test, if you remember these from PHA 205. So the value of the test to plug into the formula is going to get larger and larger. Okay, so if you want to be more confident, the values plugged here is going to be larger and larger, and this whole thing is called the width, yani half of the width probably. Okay, and so the width gets bigger. So that's where the confidence gets into the formula. Whereas for the sample size, that standard error is inversely proportionate to the sample size. Yani you have something, and at one point in time you're going to divide by square root of the sample size, or it's something over the sample size and everything is square root, depending upon what you're doing. But what matters here is that you're dividing by n, and therefore كلمة n is bigger, كلمة whatever this is smaller, yani the standard error gets to be smaller, and as the standard error gets smaller, this whole thing gets smaller, and therefore the width gets smaller. So that's in a nutshell why sample size and percentage confidence interval impact the confidence interval. And this is true for any kind of confidence interval. مش relative risk odds ratio, any kind of confidence interval, what I just explained is true. But for us in this lecture, it's true for this for this for the confidence interval of relative risk and okay, so let's continue with our formula. So here I'm going to show you the formula of how to calculate a confidence interval for a relative risk. So first thing off, the same table we've been working with, okay, exposure, not exposure, disease, not disease, with cells مثل ما مسميينهم من قبل A, B, C, D. And then you have the formula of the relative risk, which we already covered. It's A over A plus B for the risk and the exposed. And that is divided by C plus D, which is the risk in the not exposed. So you have the formula again, though you already have it. وهون في شوية يعني moving things around. You may or may not want to do it. After you calculate your relative risk, we're going to define a value A, which is the natural log of the relative risk, not of the odds ratio. This is a typo from my end. We're working with relative risk. So this is the natural log of the relative risk. Okay, remember, A is the natural log of the relative risk. Next, you're going to define a value D. That value D is the width of the interval. Remember نحن قلنا هون when I was explaining here, I told you that a confidence interval is built using the estimate. So نحن عنا the relative risk, but we actually took the natural log of the relative risk. And now we're going to add and subtract this piece right here. And I told you this piece is made of a test times the standard error. And you're going to see that in the formula. So the test 1.96, for those that remember, this is the Z value for at the 95%. Okay, so هيدي 1.96, this is not a magical value, this is the Z, يعني a test value for what kind of confidence interval? The 95% confidence interval. So that's the first part. Now the second part is the standard error. And the standard error for our calculation is 1 minus A على A plus B. هلا A على A plus B, you've already seen it. This is the incidence in the exposed. 1 minus that, it's the complement, يعني it's the non-incident in the exposed. Okay, now hopefully you already calculated A على A plus B here. So you just do 1 minus, you get its complement, and you divide by A. Divide by this value right here. Same thing, you're going to add to it. هلا we're going to do it for the not exposed. So C على C plus D is the incidence in the not exposed. You're going to get its complement, 1 minus, and you're going to divide by C. So that is the standard error, taking the square root. Okay, remember قلت لكم في square root and في sample size. So the standard error multiplied by the test, this is your value D. Okay, and now what you're going to do is you're going to take the value A that you calculated here, and one time you're going to add D to it, and one time you're going to subtract D to it. مثل ما كنا عم نحكي هون, right? Your estimate, one time you add and one time you subtract. So بدل الestimate عندي A, and one time I'm going to add D to it, and one time I'm going to subtract D to it to find the limits. However, I need to, and all of this is calculated at the natural log. So once I finish, I have to come back from the natural log using the opposite of natural log, which is the exponential. Okay, so to find the lower limit, you take A minus D, and then you're going to take the exponential of that. Okay, because we were working in the natural log. Then to find the upper limit, you take A plus D, and you take the exponential of that to come back from the natural log space. And this is the formula for the relative risk confidence interval. Okay, here we have an application. So I have two groups. I have a cohort of user of oral contraceptives, and then I have the non-exposed. So under exposed, not exposed. This is a cohort design. It's not an RCT. So people, ya amma they're using, ya amma they're not. And I'm looking at myocardial infarction occurrence. So out of the 327 women using oral contraceptives, 23 developed MI with time. And out of the 2,949 not using, 133 developed the myocardial infarction with time. Okay, so let's calculate the relative risk and let's do the confidence interval and see if we can do all of this. The risk of myocardial infarction in the exposed group, yani the risk of myocardial infarction for the user, is 23 over 327, which is 0.0703. Yani a woman using oral contraceptives has 7% chance of getting myocardial infarction. The risk is 7%. In the not exposed, it's 133 over 2,949, and that is equal to 0.0451. And therefore, her risk, if she's not using oral contraceptives, is about 4.5%. Okay, so surrounding two risks. I'm going to do the risk ratio or the relative risk, which is exactly the same thing. You take the risk in the exposed, you divide it in the risk in the not exposed, you get 1.56. So this is our relative risk. If I ask you to interpret it now, this relative risk, of course, we need to check if it's statistically significant, which we will do in a minute. However, if we pass that for a second, we talk about a 56% increase in the risk of myocardial infarction in the users as compared to the non-users. That's one way. The other way to say that a user of oral contraceptives have a risk of myocardial infarction of 1.56 that of non-users. Come in, same idea. So now we calculated the relative risk, but that's not was the application. The application was for confidence interval. All right, so remember for confidence interval, first we calculate the A value, which you're going to take the natural log of the relative risk. So that's the natural log of 1.56, and it's going to be 0.4444. Next, we're going to calculate the D value. Okay, now remember a D value is made of two parts. One part is the test. إذا عم بعمل 95% confidence interval, it's going to be my 1.96. Okay, so I'm just going to back up a few slides لفرجيكم الفورمula again. So the D is this 1.96 multiplied by all of that. Okay, I'm going to do it by pieces. So I'm going to work on this, and then I'm going to work on that, and then I'm going to add them up. Okay, all right. So first is the 1 minus the risk in the exposed, قلت لكم the complement, and then you divide it by A. Now the good news, I already calculated the risk in the exposed. So that's 1 minus the 0.0703, which I already calculated. And I divide by the cell A, which is 23. And that gets me 0.04042. If you want to do the calculation with me, pause the video and continue the calculation. The second part is the 1 minus the risk in the not exposed, so the complement in the not exposed, divided by the C cell. So 1 minus the 0.0451, hey, I already calculated that. I just do 1 minus, and I divide by 133, and then the answer is 0.00718. So these two values that I calculated, just again, I'm going to go back to the formula لأفرجيكم where I am. So I calculated this piece and I calculated that piece. I need to add them up and take the square root and then multiply by 1.96. So we were here. On the next slide, I take the first one, I add it to the second one, I will get 0.0476. So one slide, خليني ارجع one slide لورا. So that's 0.04042 plus 0.00718. Okay, if you add them up, you will get the 0.076. Okay, remember you need to square root that value, and that will give you the 0.21817. Now you need to multiply it by 1.96. This is the Z for 95% confidence interval, and that gives you the 0.4276. This is the D value. So هلا صار عندي ال A value وعندي ال D value. I'm almost done. As I said previously, you take the A and then you subtract D from it, and you take the A and you add D to it. But however, these two values are not your limits. To get your limits, you need now to come back from the natural log by taking the exponential of each one of them. So the exponential of the lower limit will give you 1.017. The exponential of the upper limit will give you 2.392. And hence, my confidence interval for this relative risk is 1.017 on the lower limit and 2.392 on the upper limit. Okay? So my relative risk is 1.56 with a 95% confidence interval going from 1.017 all the way up to 2.39. The question is this statistically significant or not? Remember, if it does not cross 1, yani if it starts and ends on either side of 1, then it's statistically significant. Obviously, this one starts right after 1 and ends at 2.39. It does not cross 1. حتى لو it's very, very close on this end, it's still not equal to 1. And therefore, the confidence interval is indicating that the relative risk is statistically significant, and we can talk about the association being present, and therefore we can interpret the 56%. One additional piece of information, if you want to do an interpretation of the confidence interval, you can say that the real relative risk is somewhere between 1.02 عم بعمل rounding all the way to 1.39 أو هون عم أقول between 2%. The increase هون عم بحكي the increase is between 2% increase or 1.39% increase, which is exactly what I'm saying here. Okay, if you take 1.017 and you round it, you'll get 1.02, يعني 2% increase, and 2.39 is 139% increase. Okay, so we've calculated a relative risk for a cohort. We interpret it, we calculated its confidence interval, and we interpret it. Let's do that for the odds ratio now. The odds ratio confidence interval is very, very similar to what we did for the relative risk, but it's actually a bit easier. Okay, so نفس الشيء, you're going to calculate an odds ratio using the formula that we covered. And if you remember, by simplification, you get to AD divided by BC. That's your odds ratio. Okay, you turn it into the natural log, so that A becomes the natural log of the odds ratio. And then you're going to define a value C, which is exactly like we always do with confidence interval. It's a test value. كمان is Z, كمان at 95%, so it's 1.96. And then you're going to multiply it by the standard error. And notice how it's much, much simpler, the standard error for the odds ratio. It's just 1 over A plus 1 over B plus 1 over C plus 1 over D. And you square root all of this, and that's your standard error. Standard error multiplied by the test, this is the C value. One time you're going to subtract the C from A, and one time you're going to add the C value to A. However, you need to come back from the natural log space by taking an exponential, and that will give you your confidence interval. So, going back to the example we calculated a few minutes ago, where we calculated a relative risk of 1.36 and an odds ratio of 1.44. You've seen this table previously, okay? And I'm going to now calculate the confidence interval for both the relative risk and the odds ratio, and I'm going to compare them. Okay, so on this side I have the relative risk, on this side I have the odds ratio. As we said, you start off by taking the natural log of the value, the estimate value, so the natural log of the relative risk here, and the natural log of the odds ratio there. Next step, you're going to calculate the standard error for the relative risk, and you're going to calculate the standard error for the odds ratio. Now, for the relative risk, we've done it in the previous example. For the odds ratio, it's fairly simple. We're just going to go one step back, one slide لورا لفرجيكم. We said, one more, the standard error is nothing but 1 over A plus 1 over B plus 1 over C plus 1 over D, and you square root. So if we go back to my table, it's 1 over 200 plus 1 over 1000 plus 1 over 220 plus 1 over 1580. You add these together, you square root, and that should give you a standard error equal to 0.1057. You may want to pause the video and do the calculation and compare your results to my result. Next step, the standard error is multiplied by the test. Again, in this example, it's the 1.96 coming from the Z test for 95% confidence. So you multiply that in the relative risk area. For the relative risk, you get 0.177. That's the D value. You do it for the odds ratio 1.96. You multiply by the standard error, which is this one right here. You get the 0.2072. And this is the C value. And we said that what you need to do now is to take A, minus C, and then you exponentiate to get the lower limit. Then you take the A plus the C, and then you exponentiate to get the upper limit. And same thing for the relative risk. You take the A minus the C, exponentiate to get the lower limit, A plus C, exponentiate to get the upper limit. And now we have confidence intervals for both the odds ratio and the relative risk. Notice Kiefer odds ratio is bigger than the relative risk. I already mentioned that. It's more inflated. And if you look at the interval of the confidence interval, if you look at the limits of the confidence interval for the odds ratio as compared to the relative risk, you will see, Kaman, that they are bigger than those of the relative risk. So how would I interpret these results? I'm not going to go over the relative risk. I did it for the previous example. I would say that I have an odds ratio of 1.44, meaning that the exposed have 44% higher odds of the disease than the non-exposed. If this odds ratio is statistically significant or not, I'm going to look at the confidence interval. It starts at 1.17 and it ends at 1.77, meaning that it does not cross 1, and therefore value 1 is not an acceptable value, and therefore I'm going to reject the null hypothesis, and therefore the odds ratio is statistically significant. أنا كتير عم بعطي details. When you're doing your thing, you don't have to give all the details. You just say confidence interval does not cross 1. The results are statistically significant. Okay? And if you want to add more explanation, this odds ratio that we calculated is a point estimate. The real odds ratio in the population can be as low as 1.17 or as high as 1.77. All right, so confidence interval, the confidence level of the CI could be 95 or 95%. The width of the CI is the precision, and the sample size are related. So Anna, I already touched on that. I already explained how these three things are related, but this is the PowerPoint explaining it. So if you fix the sample size, as the confidence level increases, so does the width of the confidence increases, and therefore you lose the precision. Okay, so let me go back to the chart and see if I can explain that. Remember, the formula of any confidence interval is that it's the estimate plus or minus the test value times the standard error. Okay, sample size is included here in the reversal relation, whereas the test is what's related to your how confident you want to be. Okay, so I mentioned that. So if you keep your sample size fixed, كل ما بتغيروا how confident you want to be, the test will gonna change proportionate to how confident you want to be. More confident, a larger test, معناتها a larger width, معناتها a lower precision. And for the sample size, come in for a fixed confidence interval. If you do not, for a first confidence, percent confidence, the standard error is irreversibly proportionate to sample size. As the sample size increases, the standard error decreases, the width decreases and the precision becomes bigger. Okay, so that's what I'm saying in the slide. Here, the same thing about sample size, exactly what I said. Um, Also, I kind of like mentioned that you can test using a confidence interval, but you can also test it using a p-value. A p-value, you will get it using the chi-square test, testing the following null hypothesis. قلت لكم it's the null hypothesis is that the population relative risk is equal to 1 if you're calculating a relative risk, or the population odds ratio is equal to 1 if you're calculating an odds ratio. And I said that some authors uses this sign to refer to the population value. Um, there is a relationship that I mentioned between how confident you want to be and the p-value or the alpha that you're testing. But for now, this is just an example how if you are calculating a relative risk, let's say مثلا I'm calculating a relative risk and it came out equal to 2 for a sample size of 200. So the sample size is not changing. As I change my percent confidence from 90 to 95 to 99 to 99.9, okay, you should by now know that what is going to change is the test value. This test value is going to get bigger, yani the width is going to get larger. And that is evident looking at the values. So the confidence interval started up being 1.8 to 2.3. As the confidence increases to 95, the interval has to get larger. The way an interval gets larger is by the interval moving opposite direction. So the 1.8 is going to get lower to 1.6, and the 2.3 is going to get larger to 3.1. Let me explain that using شوية drawing. Okay, so if you calculated a confidence interval, at that confidence interval, مثلا 90% confidence interval was here. Okay, remember the way you've calculated is that you had an estimate somewhere here and you went up and down. If you change your confidence interval to 95% confidence interval, البوينت بعده محله, but you're going to go up and down a longer distance, and therefore the limits are going to be here and here. So if you compare the pink borders to the green borders, you will notice that the upper one moved up and the lower one moved down. Okay, and if you want to also do the 99% confidence interval, the point estimate is still here, but the distance traveled up and down is even larger, and therefore your confidence interval could be like this. And again, what happened is that the upper interval moved up and the lower interval moved down. Notice how intervals are moving into opposite direction. They either uh, they get far away from one another or close to one another. Okay, and that's what we're seeing in this slide. So the interval started between 1.8 to 2.3. It's getting larger, so the 1.8 becomes 1.6 and the 2.3 becomes 3.1. As you go to 99%, the 1.6 becomes 1.2 and the 3.1 becomes 3.9. And as you go to 99.9, the 1.2 becomes 0.7 and the 3.9 becomes 4.8. Okay, notice how the intervals are moving away on opposite directions. Another thing that I want to point out, notice Keith, this one was statistically significant because it did not include 1. The second one was not statistically significant because it did not include 1. The third one was not statistically significant because it did not include 1. However, the last one failed its statistical significance because it does include 1. Okay? And I'm going to explain what is happening here, or at least I'm going to tie it up to p-value. So, so let me clean up a little bit. Like in what we had a minute ago, we had the percent confidence interval, the percent confidence, okay, 90, and then we went to 95, and then we went to 99, and then we went to 99.9%. Okay, and we were looking for value 1 if it was included or not, because value 1 is the null hypothesis value, and it was not included in the first one, and therefore we were declaring statistical significance. Okay, SIGN is significant. In 95, value 1 was not included, so we were declaring significance. 99% confidence interval Kamen 1 was not included, and we were declaring significance. And the last one, value 1, was included, and therefore it was not statistically significant. All right, remember, now there is a one-to-one relationship between the interval and the alpha. So the alpha that relates to 90% is 10%, 0.1. مع بعضهم they add up to 1. The one that relates to 95% is 5%, 0.5. The one that relates to 99% is 1%, and 0.01. And the one that relates to 99.9 is the 0.001. Okay? Now, we know that the results were significant in the first one, meaning that we rejected, therefore the p-value was less than alpha. That alpha was 0.01, so I'm going to write p-value less than 0.01. In the second one, also there was statistically significant, yani we rejected, yani the p-value was less than alpha, but this time alpha is 0.05, so the p-value was less than 0.05. The third was also statistically significant, yani p-value was less than alpha, but this time alpha is this one, yani 0.01. And the last one is the interesting one, because that's where you failed to reject. It was not statistically significant, and therefore the p-value was greater than alpha, but it was this alpha, which is 0.001. Okay, what that means, have we calculated a p-value instead of confidence interval, we would have gotten a p-value that was less than 0.01. However, it would have been greater than 0.001. Okay, and this way, using my confidence intervals, I can figure out what would be my p-value. And the reverse is true. If you're given a p-value, you can figure out which confidence interval will include one and which confidence interval will not include one using this rationale that I just explained. Okay, so let me give you the reverse of it. So if you were told that we calculated, let's say, خلينا هالمرة نحكي على odds ratio. We've calculated an odds ratio, and that odds ratio came out to be 3.2. The p-value for that odds ratio came out to equal 0.03. And then you're asked, if we were to calculate a 90% confidence interval, a 95% confidence interval, a 99% confidence interval, which one will include value 1 and which one will not include value 1? Okay, so remember the alphas that correspond to each one of them. This is an alpha of 0.1, this is an alpha of 0.05, and this is an alpha of 0.01. I already have my p-value, so I know that my p-value is actually less than this one, less than 0.1. When the p-value is less than alpha, you're going to reject the null hypothesis. Okay, يعني في significance, and therefore your value 1, the 1 is not inside the interval. Moving to the second one, my p-value is 0.03 compared to 0.04. P-value كمان is less than alpha, 0.05. So again, you're going to reject. Again, you're going to declare significance. And therefore, again, your confidence interval at the 95 will not include 1. However, when you come to the last one, you compare your p-value 0.03 to 0.01. This time, your p-value is greater than this alpha. Can you excuse how I'm writing things? And therefore, you're going to fail to reject. And therefore, it's not statistically significant. So ما في statistical significance, and value 1 will be inside the confidence interval. All right? Okay, so continuing with the confidence interval with the relative risk and odds ratio. This time I'm keeping the confidence interval the same, so 95, 95, 95, 95. The relative risk is 2, it hasn't changed, but I'm changing the sample size. And we have discussed this. We said that كل ما sample size is bigger, كل ما confidence interval is narrower. So starting off with a confidence interval of 0.9 to 4.6, if you're going to move to a larger sample size, your confidence interval is going to get narrower. And the way it gets narrower is that by the limits moving towards one another. So the 0.9 moves up to 1.4 and the 4.6 moves down to 3.8. A larger sample size, same thing. The 1.4 moves up to 1.6 and 3.8 moves down to 3.1. And finally, for a sample size of 400, the 1.6 moves up to 1.7 and the 3.1 moves down to 2.5. And you can appreciate that bigger sample size is giving you a narrower confidence interval, more precise, but also you started off with not statistically significant into statistically significant, and that has to do with power of the test. Remember, larger sample size, more power. Okay. So this is the relationship between p-value and confidence interval that I was discussing a minute ago. I have a relative risk of 2 for confidence interval 90, 95, 99, 99.5. Okay, so my relative risks are the same. However, the percent confidence are different. And I told you that there's a one-to-one relationship between the confidence and the alpha. And these were the values of the confidence interval I showed you. And therefore, significant, significant, significant for the first three, not significant for the last one because it includes 1. And then if it's significant, يعني p-value is less than alpha, that specific alpha. كمان significant for the second one, نفس الفكرة. The only time that it's not significant is for the last one, so p-value is greater than 0.01. And therefore, you can figure out that your p-value is going to be between 0.01 and 0.001. Okay? And here, so giving a set of confidence intervals for the same data set, you can figure out your p-value. And the opposite is true مثل ما قلت لكم. So here's an example. The relative risk is equal to 3 and the p-value is equal to 0.021. And if we create a 90% confidence interval and 95% confidence and 99 and a 99.5, which one of these confidence interval will include 1 and which ones will not include 1? So I did this something similar to that in the example. I'm going to leave you to work on it by yourself, and if you have a question, you can share that during the lecture. Now, I've mentioned at the beginning of this lecture that this lecture is going to be long. We went over an hour now, so I'm going to stop. This will be part 1, and I'm going to do the rest of it, which will be part 2. Hopefully, I'll be able to finish in part 2. Maybe we'll need a part 3. So I will make sure that to notify you which one is part 1 and which one is part 2 and 3. All right.